We didn't know imaginary solutions were an option, but they are now. What is an imaginary solution going to contain? What number is our imaginary solution going to involve, Andy?
Square root of -1.
Right, which is represented by I, our imaginary number I. So now this brings us into a whole new world of imaginary numbers, and those are more answers that we can write down. So looking at problem 1a. When you're solving, set it equal to 0 first. That's not new. That's pretty much something we've been doing for a while. So I'm just going to subtract 3x over, and I get 2x cubed minus 5x squared minus 3x equals 0. When you are factoring, always check for a GCF first, and we in fact do have a GCF. It is x. So factor that out. Now we need to continue factoring. How can I factor what's inside the parentheses? 2x squared minus 5x minus 3. Your x squared value has a coefficient that is not 1 in front of it, which means we have to use the garbage method. So factoring what's in your parentheses, I'm doing 2 times 3, negative 3, gives me negative 6. I'm going to use negative 6 and 1 as my factors to rewrite this. 2x squared minus 6x plus x minus 3. Group the first two and take out their GCF. Group the second two, those only have a GCF of 1. So you're not really taking anything out other than that 1. And now we have 2x plus 1 times the quantity x minus 3. And we have factored what was inside the parentheses. Don't forget that we had this x factored out as a GCF. From there, you are solving, you are finding the solutions, you are finding the roots, you are finding the zeros. Remember all of those words, roots, solutions, zeros, they all mean the same thing. We have to find our answers. So set each portion of this equal to 0. X equals 0, 2x plus 1 equals 0, and x minus 3 equals 0. From there, x equals 0. X equals negative 1/2. And x equals 3. We started with a cubic polynomial, and we have 3 x values at the end, because cubic is degree 3. Bless you. With problem B, you're going to set it up the same way. Start by setting everything equal to 0, and then factor out the GCF. What's our GCF for this one? Trissa? Good. Look inside your parentheses. What factors of 4 could give you 2? Are there factors of 4 that can give me 2? No. I've only got 1 and 4 or 2 and 2. Nowhere can I add those or subtract those to make them equal 2. So, think back to our homework. What did we do when we had a quadratic and we couldn't factor it? How did we solve that quadratic that we could not factor? Problems 13 and 14. We couldn't factor them, but we had to solve them. Dom? Exactly. This quadratic cannot be factored, but it still can be solved by our friend, the quadratic formula. So, the 3x to the second. Don't worry about that right now. We factored that out. That's one of our factors. Now we need to solve what's in here in the parentheses using, like Dom said, the quadratic formula. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Just keep simplifying. What can I do with this square root of negative 12? There are two things that I can do to simplify it. We know we can't have the square. Go ahead, Andy.
Take out the 4, so very fun, and then take out the negative, so I.
Very good. Simplify it using I because we don't want the square root of a negative. Simplify it by taking out the perfect square. So off to the side, if you want to think about this, what we're doing is we're taking the square root of negative 12. We're making the square root positive by taking out I. Then we're taking out the perfect square. And we have, instead of the square root of negative 12, we have 2 plus or minus 2i root 3 over 2. So you've just replaced the square root of negative 12 with 2i root 3. And one more thing. Haley? Good. You can simplify all of these 2's. So finally I end up with 1 plus or minus 1i, or just I, root 3 over 1. I don't need to write over 1, so I'm just going to leave my answer as that. How many answers are there? 2. Connor?
Well, we need your 3x squared.
Yes we do. We're not there yet. But right now, I've got my 2 answers here, right? Because it's plus or minus. Now, like Connor said, hold on, we need our 3x squared. He's absolutely right. All we did was solve one factor of this. We solved x squared minus 2x plus 4. We also need to solve this 3x squared. How do we solve the factor? Take the factor, set it equal to 0. X squared equals 0. X equals 0. Now I have a little bit of a problem with this. We have 1, 2, 3 answers. But this came from a quartic polynomial. Shouldn't I have 4 answers? Andy?
The x equals 0 has quadratic because it's squared.
Yes. What's that called when it appears twice? When your answer appears twice? X equals 0 and x equals 0? Go ahead, Andy. Yes. Very good. Awesome. This has a multiplicity of 2 because, look, it's an x squared value that we're solving. We don't write plus and minus 0 because it's just 0. But because that has a multiplicity of 2, that represents 2 answers. So we can think of having x equals 0 appearing twice. There are 2 answers. And then we've got plus or minus. Those are 2 more answers. Altogether, we've got our 4 answers, and life makes sense. Quartic polynomial, 4 answers. The next one you're going to like because it's already factored for you. What are the real or imaginary solutions? Like I said, it's already factored for you. So all you have to do is take each factor and set it equal to 0 to solve. X squared minus 1 equals 0, and x squared plus 4 equals 0. I'm just going to add 1 to both sides and then take the square root. So x equals plus or minus 1. And then I'm going to subtract 4. And here, when I'm taking the square root of negative 4, that creates an imaginary solution. X equals plus or minus 2i, because the square root of 4 becomes imaginary. The square root of negative 4 becomes imaginary. I have a question for you guys. How else could I have solved this right here, the x squared minus 1? How else could I have solved that to get the same answers, plus and minus 1? I think it's easier this way. You guys probably do too. But there's another way I could have solved that by factoring, even though it's not a trinomial. And it's not the quadratic formula. I could factor that a certain way. Connor, think about what you asked me before. Or everybody, think about what Connor asked me before. Go ahead, Connor.
Difference of squares.
Yes, we could factor this by difference of squares because x squared is a perfect square and so is 1. They're being subtracted, so that's the difference of squares. Remember, when you're factoring with difference of squares, all you do is you take the square root of both. One sign is positive, one sign is negative. So x plus 1 and x minus 1, if you would go to solve that, you would get the exact same answer that we got over here when we took the square root. Okay? Not necessary to do it 2 ways, but just showing you, you could approach it either way. And then we have problem B. Get everything on the same side of the equation. And make sure you combine your like terms of x cubed there. Everything equal to 0. Everything on the same side of the equation. Now factor out your GCF. Somebody give me GCF. Connor. Good. Somebody give me what is left in our parentheses after we factor out that GCF. Dom.
X squared minus 5x plus 6.
Good. Somebody else tell me, how can I take what's in those parentheses, that quadratic trinomial, how can I factor, give me the 2 factors of that quadratic trinomial. So just factor x squared minus 5x plus 6. Katie.
X minus 2 times x minus 3.
Very good. Don't be fooled by this tricky little 6. 6, it's a positive, signs are the same. So like Katie said, use 2 and 3. You can't use negative 6 and positive 1 here because signs have to be the same. And then we also have our x cubed out in the front as our GCF. And now somebody else give me my solutions. Haley. Good job. Why does it look like I only have 3 answers? Go ahead, Haley. Yes. Multiplicity of 3 means 0 is represented 3 times. 3, 4, 5, coming from the quintic polynomial, and we're good. Now, the reason that we did this stuff yesterday is because in your homework you're going to have some problems where you're going to need to factor not just using these methods we talked about today, but the new stuff we talked about yesterday. So let's just add an example problem in here since that stuff was new for you guys. Let's add x to the 4th minus 3x squared equals 4. So say we are given this in our homework. We know that we want to get the set equal to 0, so we're going to have x to the 4th minus 3x squared minus 4 equals 0. Now I have a quartic trinomial. There's no GCF that I can factor out here, so I just have the quartic trinomial. You learned how to factor these yesterday. Factor your quartics just like you factored your quadratics, except you're using x squared. So my factors of 4 with different signs to give me negative 3 would be a negative 4 and a positive 1. And then since this whole thing equals 0, we can solve from there. X squared plus 1 equals 0, and x squared minus 4 equals 0. X equals plus or minus I. X equals plus or minus 2. Our imaginary and our real answers. And if you notice, this looks a whole lot like the got it question number 1, except got it number 1A was already in factored form. We just factored this one and then solved from there. So this is how you would do a quartic trinomial in your homework. And then let's do one with the SOAP method of factoring also. So if you were given x cubed minus 1 equals 0 in your homework and you were told to solve this, we want to use the SOAP method. So, same sign, opposite sign, always positive sign. When we solve this, one side's going to be really easy. X minus 1 equals 0. So we know that x is 1. But then we've got x squared plus x plus 1 equals 0. And that one's not as easy to solve. Because our factors of 1 are only 1 and 1, so the only thing we could add them together is to get 2. And our middle term there is not 2, it's 1. So we cannot factor this quadratic. What do we need to do? If you can't factor the quadratic, Haley?
Quadratic formula.
Yes. So we have to use the quadratic formula here. X equals the opposite of b, plus or minus square root b squared minus 4ac all over 2a. And you will end up with negative 1 plus or minus I root 3 over 2 as your other answer. So if you're doing the SOAP method, more than likely you're going to also have to use the quadratic formula. Okay, after you factor using SOAP, then quadratic formula. And your next slide kind of just sums up all kinds of different ways to factor. And if I were you, if you're going to use this chart, I would kind of put a side note that says, when all else fails, try the quadratic formula. So anytime you can't factor a quadratic, make sure you're remembering that you can use the quadratic formula. And your homework is just going to be based on that stuff today, the factoring and then the solving. It's on page 301. And we're going to do 10 to 24, just the evens. 10 to 24 even on 301.